Hi everybody, this is the Happymath channel. In this video, we continue with the integration technique. As you know, there are still many integration which you cannot yet do. So in fact, many functions cannot be integration at all. Although virtually all functions can be differentiated. However, some function can be integrated by the technique which you have not yet met. Integration by part is one of the those techniques. In this video, I will teach you a basic integration by parts. For example, let's come back to the basics of the integration by part. First of all, I want to differentiate of the main function is x times with sin x. So x times with sin x is a function with the two main functions. Two main functions, one of them is x and another one is sin x. So when you take the derivative of this function, you have to take the one by one the main function. First of all, you have to differentiate x. So first number is sin x times with the dx. So another one, we continue with the differentiate of the sin x function. So the second term is x times with dx. We call this one is the chain rule, as you know. So from this one, you take the differentiate. So when you take the integration, you take a inversely technique of the derivation. So integration of the dx times with sin x equal to integrate of sin x times with dx. We just write down the symbol of the integration in the first function like this. So when we rearrange of this expression, you will get this one. I change the position of the x times with this sin x from the right hand side become to the left hand side, and when I change that, I have to change the size of this function. From the negative, I change it to become the negative. From the positive becomes the negative, and the inverse way. So as you can see, we can calculate the main integration x times with d of sin x. We can calculate it from this one because you got very easy to calculate the integrate of differentiation x sin x. It will be x times with the sin x. Because of this couple is the inversely technique. So when they stand by near together, you can change it become to invisible. Okay. So what is the exactly of the integration of x times with d sin x? Integration of x times with d sin x is x times with cos x times with dx. Because cos x times with dx is the result of the integration of the d sin x. So maybe you can understand this one. So I can change from this integration become to this one. To make it easier, I want to change this from the u and v explanation. When you take the differentiate of the u and v, you first calculate the differentiation of v and second one derivative of u. So after that, you can move the term of this expression like this. Okay. So the position of the integration u dv is unchanged. You have to change the position of the v du. From this one becomes this side, and you have to change from the positive side become the negative side. You got this one. Okay. So when you have let me take more clearly about this one. When you take a true function, maybe a and db, it means the main function is a and b. Integration by part tell me that you have to take the two function time together and minus of the integration. The position of the a and b have to change together. This means we got b here and d of a. Okay. So another one, you got fx times with d of gx. and you want to take integration by parts, it means you have to take the dx, fx time with gx, and all of them have to minus of the integration of change the position of the fx and gx. Gx you got here, and you take diff of fx. That's quite easily ways to understand. First one, you time two main functions together and minus of the integration with the changing position of the two main functions. Okay, so let me apply this technique to a specific exercise. First example, the integration of the x time with e power to x dx. First of all, you can see that we have a two function outside of the dx, so you have to move one function have to be from outside of the dx become to the inside of the dx. You will got the two ways to get this one. First of all, I want to change the position of x become to the inside of the dx, and you will got d of x squared power divided by 2. So from this one, you will take the two main functions times together. It means e power 2x times x squared divided by 2, and minus of the integration. You change position of the two main function in this one. It means x squared divided by 2 times with dx. So d e power 2x, it means e power 2x times with dx. So from this one, you can change, you don't need to calculate the integration of this function, you just calculate of this function. So this is maybe more complicated integration. You shouldn't do that. So you got this result because you change the position of the x from outside become inside the dx, and you got a more complicated function. You shouldn't do that. So another way to count, you can change the position of the e power 2x from outside become to the inside of the dx, and you got the new function is d of e power 2x. Because d e power 2x, when you take the differentiate, you will get the e power 2x times with dx. Yeah. So from this one, you take the x power 2ex, two main functions times together, minus integration of e power 2x times with dx. So this one is very easier to calculate. Integration e power 2x times with dx will be equal to d of the e power 2x. You change, you move e power 2x from outside become to inside the differentiation. So we got this one. Two simple in nearby together, so you can consider it is invisible, and you plus c at the end of the integration. Quite easier. Okay, we continue with the second example with a high difficult level. At the first example, maybe I want move x become to inside of the dx, and I will move this one become to inside the dx, e power to 2 times with x. But if you want to move e power to 2x here, you have to change from dx become to the d of the 2x. So when you want to change from dx become to the d of the 2x, it means you have to time with 2. So for unchanging the main integration, in this example, you time with 2, it means you have to divide by 2 at the same time. So I will want to time with 1 over 2 outside of the main integration, and dx become to the d of the 2x. So e power to 2x d of 2x, it means I can move it become to inside of the integration. Inside of d. So d become the e power to 2x, And you got the two main function here is h and e power to 2x. First one, you following the integration by parts, you time two main function together minus integration with the new integration change position of the main function. This means e power to 2x times with dx. And don't forget the 1 over 2 outside. Because this one we got to time 1 over 2 in this position. Okay. So e h times with h power to 2h is unchanged. In the same way, you want to integration of the e power to 2x, it means you have to change d become to the 2x. And time with 2 here, you have to you need to multiply 1 over 2 outside. And you will see this. When 1 over 2 outside, very easy to calculate integration of this function. So we got, and don't forget the time with 1 over 2 outside. Let's see. And that expand this one, you will got the main result is 1 over 2 h times with e power to 2h minus 1 over 4 of e power to 2h and plus c. And this function you can integrate by substitution, because when you take a substitution in this example, very difficult to calculate the e power to 2x following up h, because it is a two main function with a different, totally different function between them. So you have to apply the integration by parts. Go on with this equation. This expression. Now you can change. You can see this. We have the two main functions, the h and length of the lineage of the time with the dh. So when you take when you want to calculate this one, you have to move one of them from outside become to the inside of the derivative. So I will change first way. I will change from outside h function become to the inside of d. I keep unchanged of the logarithm of h like this, and dx become to the h power to 2 divided by 2. So you have to make new main function and time them together and minus integration of the d of the lineage. When you take the d of the lineage, you will got the new easy way function time with dx divided by h. So simplify this one, you will got that h 1 over 2 times with dx and lineage h squared power divided by 2. We go on with this one. Move h from outside become the inside of the derivative. This means h power to 2. So the main function is one over 4 of the h squared plus c. Okay. Maybe when you watch my doing, you can stop video and do this function by yourself, and after that continue and play continue, and you will see the result and compare my result with your result. Example 4, very easy to count. Now I don't need to change. I don't need to find another function because it's quite easier to see. Logarithm of x and dx is the two main function, and apply immediately integration by parts. You will get us. You will get us. Like linear time with the dx is the product of the two main function and minus the change position of this one. It means x will become to outside and limit become to the inside of the derivative, and limit time with x minus with x dx divided by x. So very easy to calculate this one, cancelling x and x, and we got that the integration of the dx. So the result of the integration is x and plus c at the end. Okay, new trigonometry function. This function is quite complicated with the limit or the e power to x. So you have to change. You have to take the choice. You will move x become to inside of d, or you will move the side become to inside of d. So my best choice is I will move the side from the outside become to inside of the trigonometry should be from outside become to inside first. I can change sine x become to inside of the dx. It means it will become to change from d of the cos x. So you got two main functions in this way, and first one is minus x and second one is cos x. Minus of cos minus cos x times with dx. It's okay, integration by parts. First term is unchanged, and the second term simplify them, and you will got the integration of the cos x times with dx. And move cos x from out to inside of dx, it becomes to sin x sine x, and you plus c at the end of the process. Okay, continue with this way. Very easier. You take 3 outside, and this one become too easier to take our option. You will move e power to x inside of the dx, and 3 is still unchanged. And after that, you will got a power to 3x minus integration of the e power to x times with dx, and 3x power e times with e power to x minus 3 e power to x plus c. Okay, don't stop because practicing is the king. Integration by parts, as you have practicing a lot, so this is only the 6th example. You should continue with the 7th example in this one. And in the same way with the 6th example 6, you should move e power to x from outside become to inside of the dx, and you shouldn't care about the x power to 4 here. It's very easy to solve. And this one you will find the two main functions. H power to 4 is the first, and the second is e power to x. Integration of ex d of x plus 4. First one is unchanged. And how about d of x plus 4? Very easy. dx plus 4 is mean d of x, because plus 4 or plus c or anything constant number differentiation always equal to 0. Minus e power 2x plus c. Okay, maybe you understand. Okay, more harder. You continue should move e power function become to the inside of the dx, but it is not easy way like the previous example. You have to change dx here become to the d of 3x plus 1. First one, you want to change from dx become to the 3x plus 1. First process, you have to change dx become to the d of 3x. It means you have to time with 3. So for unchanging this integration, you have to divide by 3. It means time with 1 over 3. And then you change from d of 3x become to the dx 3x plus 1. It means you have to plus 1 in this position. And now very easy to take the e power to 3x plus 1 function become to the inside of dx. It will be equal to oh sorry, it will be equal to x times with d of 3x plus 1. And you know two main function in this way. Lower x e 3x plus 1 and minus integration of the e power to 3x plus 1 times with dx to change position of the two main function. So the first term of this expression is unchanged. And in the same way with this process from this one, you time with the 1 over 3 and plus 1 with the dx. So after all, the result of this integration is, and don't forget plus c at the end. Okay, very easy. And now the two main functions e power to x and cos x. So which one you should choose to take the inside of the dx? Different totally function e power to x and cos x. So first of all, I want to move from e power to x inside the dx. So dx in this way, and you got the two main function is cos x and e power to x minus with e power to x times with d of the, sorry, this is cos x. And the first term is unchanged. Minus with e power to x times with minus sin x times with dx. And minus sign here is we combine with the minus and it becomes to the plus. Times with dx. Okay, so we continue with only this integration one more time. Let's be patient. I move x e power to x inside of dx one more time, and apply the integration by parts. E power to x times with sin minus time with D side, and it's become to EX time with sine X minus to cos time with AX and time with DX. So do you recognize this integration exactly equal to this integration? So we substitute from both of the both term of the result, the first of this integration. You will see this apply in this way. Apply in this one, you will see that the integration of e power 2x time with cos x time with dx will be equal to first one is cos x time with e power 2x plus with this one, the star here, and the star here equal to e power 2x time with sin x minus this way. So when you change the position from the minus cos x e power 2x time with dx here, we come to the another side of this expression. You will say that it is a 2. This one is 2 integration of the two of the integration. So just take this term divided by 2, and you will got the result of this integration. Okay, that's this is one more example for you to practicing about the integration by part. So do you by yourself apply the another own ways in the 9 example for practicing this one. So thank you so much for watching, and I hope this video help you get more understanding about the integration by part. So see you in the next video. Thank you so much, and if you like this video, please subscribe and share this video for your friend. Thank you so much.